Hello and welcome to this Tovi tutorial. This tutorial is going to cover the Flux partitioning tool. Now before getting started, there's a few processes you'll want to do before using this tool. You'll want to use the quality screening tool and get rid of any outliers in the variables you plan to partition and also in some of the inputs you're going to use in the model. Next, you'll want to go to the biomet gap filling tool. You'll want to create continuous data sets for the variables you plan to use inside the model. For example, air temperature and VPD. This particular tool could be optional, but it's the storage correction tool. This tool creates the NEE variable from CO2 flux and the CO2 storage. And then finally, what you'll want to do is make sure you have a continuous gap-filled data set. In this case, you use the MDS gap filling tool, and you can do that for FCO2 or Net Ecosystem Exchange, for example. Let's go ahead and jump into the tool. We click on the toolbox menu here and click on the partitioning tool. Now this particular tool is based on the nighttime partitioning model. And in a nutshell, what you're doing is taking Net Ecosystem Exchange, and then you're using your ecosystem respiration, and that's being computed by an extrapolation of the nighttime values of your ecosystem respiration into the daytime, and it uses short-term temperature sensitivity response functions. And then from there, you can calculate your gross primary production, which is GPP, sometimes also referred to as gross ecosystem production, or GEP. Now this particular tool is based on the papers written by Marcus Reichstein. Again, you can click on this acknowledgement tool, come in here, and here is the paper and the reference. Now if you click on this icon here, you can see the details of all the other authors that are involved on this paper. There's some shortcuts and icons that you can use to potentially reach out and ask questions to some of the authors on this paper. Now the code itself was originally written by Marcus Reichstein and his group. It was written in PV Wave. Now just recently, Gilberto from the Ameriflux network was able to rewrite this code in the Python language. Now this code is what's used by the Ameriflux and FluxNet networks, and it's also used in the OneFlux code set. So let's jump back into the tool now. I'm going to quickly go through this. You can see that there's a couple variables available for nighttime partitioning. I'm going to go ahead and choose the CO2 flux. Over here, we choose a solar radiation variable for determining day or night. I have my shortwave incoming radiation. Now the air temperature, I can choose a gas analyzer eddy covariance temperature, or I'm going to go ahead and choose this one, which is a continuous measurement over time of the air temperature from the biomet system. And then I have a VPD variable, which I've merged to have a continuous data set of as well. So when I'm ready, I come up here and simply click on the Start button. Now the code is running and partitioning that variable, and we're presented with three charts. We have our original CO2 flux, we have a new GPP, and a new ecosystem respiration. What you'll immediately notice is we have a gap here in the gross primary production. Now the ecosystem respiration model works, and that is computed, but the GPP is not computed because we have not filled in the gaps in our original CO2 flux. So let's go back to the settings, and you can click on this icon here to get there. And let's go ahead and choose a different variable to do the partitioning on. Now earlier I mentioned about making sure to try and do compute NEE and also a gap-filled version of that variable. So I have a gap-filled Net Ecosystem Exchange. Again, I'm going to use shortwave incoming radiation. I'm going to use my biomet sensor for air temperature, and I'm going to use my VPD merged variable set, which is continuous. We'll hit the Start button again, and the code is rerunning with this new set of variables. And now we're presented with three time series charts filled in. We have our Net Ecosystem Exchange, our gross primary production, and our ecosystem respiration. Now, if I also want to look at these charts in a different way, we have this diurnal button up here. Clicking on there presents us with 3 other ways to look at these variables. These are the average ensembles over the time period of our analysis. At the top, we have a net ecosystem exchange in red. That's our original variable. We have our GPP, the new variable, in green. And in the blue on the right here, we have our ecosystem respiration. Now, if we're happy with all these and we want to save them, we want to create these new variables, add them into our data set, and use them for further analysis, maybe do some QC on them, we can go ahead and do that. And we want to create those and save the work we've done. We come up here and click on this Done Nighttime Partitioning. And that'll conclude this particular tutorial.